It might be a good idea once you write your proof to have me look it over, so you know if it's actually going to work. And I'm pretty lenient. I mean, if your explanations sound good to me, I'll give it. I'm not super particular on how you state things. Some things you can't do, though. So, wonder why that stopped working. Turn to the last page. The last page is a little bit different. On the last page, I give you that angle 4 is 125 degrees, and angle 8 is 55 degrees. And I want you to prove to me that the lines are parallel. Okay, how do you do that? Yes, we know all four rules work. Although these would be consecutive exterior, we don't know anything about consecutive exterior. So we do need to do a little bit of math. So, okay, so if I know that 8 is 55, what do I know about 7? 125. Okay, and then, well, we really don't need to go further than that, right? What should we say? So we could say the lines are parallel because angle 4 equals angle 7 by what rule? Now wait a minute. Let's read the corresponding angle postulate again. When two lines are parallel lines are met by a transversal, corresponding angles are congruent. So this postulate says if parallel, that implies, this is math lingo, that the angles are congruent. Right? That's what we stated. We accepted. If we know that the lines are parallel, that implies that the angles are congruent. Did we say if congruent, that implies parallel? No, it's not the same. And let me give you an example. If you're a boy, then you're a human. Is that true? If you're a boy, then you're a human. What about the converse? If you're a human, then you're a boy. No, that's not true. So the converse, we can't just say, oh, it's true by the converse of the corresponding angle postulate. So we made a mistake. When we wrote the postulate, we didn't put enough information in, which is rare, right? Usually we have to be worried about sticking too much in. But in this case, we need it to work both ways. We need the original hypothesis and the converse. Converse just means you switch the if and then. So we need the original hypothesis and the converse to be true. So we can do this fancy thing that says if parallel, well, actually we don't even need if. This little equals with an arrow means implies. So we can write parallel implies congruent, and we can also do the same thing backwards where congruent implies parallel. So that this hypothesis works both ways. If parallel, then congruent. If congruent, then parallel. We call these statements if and only if statements. So let me think of one, an if and only if statement. If you're a boy, then you have an X and a Y chromosome. The converse would be if you have an if you have an X and Y chromosome, then you're a boy. True, although in today's world that's a little more foggy than I expected. So maybe that wasn't the best choice. So we're going to update our postulate. we are going to state both ways. Now, here's the long way to do it. Wow. Yes. Yeah. Good shot, though. It's not mine. Okay, so we could state the corresponding angle postulate like this. If the lines are parallel, then corresponding angles are congruent, and if corresponding angles are congruent, then the lines are parallel. But we're lazy in math, so we've come up with a faster way. So this is what we're going to write. Corresponding angles are congruent and we're going to write if and only if the lines are parallel. And that if and only if means it goes both ways. But we don't like writing out if and only if. You can if you want. So we've invented an abbreviation. If. That means if and only if. If and only if the lines are parallel. Yeah, this is the update to the corresponding angle postulate. What? I am the master of all time and space. Was that your question? So, yeah, we just did it. This is illegal. So, now the proof is simple. 125, 55. Well, using the definition of linear pairs, this is 125. And because 4 and 7 have the same measures, the lines are parallel by the corresponding angle postulate. Sure, go ahead. Okay, so in the next 5 minutes, go through and write up that proof. If you want me to read any of your proofs, I will. Okay, let's do it.